Hi guys, my name is Poorna and I manage the product and application security team for Netflix. Conveniently, my partner Rudra had a headache this morning, so we have to manage without him. I don't have a $60 gift card. What I have is a deck of cards with all Netflix originals. And I think I'll give it out to the most interesting question that comes out of this talk, so I know you guys are attentive. Today we'll talk about how we think about security for billing and payments. My team, Product and Application Security, is in charge of security for the Netflix product. And we work with different teams, and you know how Netflix is, like we run on tens of thousands of instances on the AWS cloud. We are always trying to strive for a very high velocity of feature delivery. And the charter for my team is to enable this agility for these teams while at the same time maintaining security for the product. And while we try to do that, we do security assessments, we do code reviews and like the typical run-of-the-mill, but at the same time we are putting out tools, libraries, self-help applications and services so that the teams can consume security in a sort of like what we would like to have a prescribed way and move fast. So specifically for billing and payments, the first thing we think in terms of security is segmentation. So there is if you think of this is a super simplified architecture of how Netflix looks like as a company infrastructure. This is probably composed of tens of thousands of instances across AWS cloud in different regions, and and there's like all kinds of browsers and thousands of different kinds of Netflix devices talking to our infrastructure. So what we do is, first of all, segment all the sensitive data like credit card information and payment or customer information, all that into a separate segregated environment, and any of the applications such as payments, billing, they go into or any of these applications that either process or access this sensitive information go into the segregated environment. When I say segregated environment, we are segregating it at the level of AWS account, network level, security groups, and probably have more controls in terms of like who can access this environment, who's authorized to make changes here. What about file integrity monitoring, configuration management? We also have ingress and egress filtering and monitoring, so that this is really like our locked down environment. The next step about that is this is also the environment that will undergo third-party evaluations for PCI compliance. Right. Once we have separated this infrastructure out, then we think about what other security, so now we have sensitive information in in this environment. If the worst scenario happens and somehow a part of our infrastructure gets compromised, then we still don't want to protect the sensitive data. So one of the tools the security tools for that is tokenization. Tokenization is saying, for every credit card, I'm going to use a surrogate value that represents it and use that across my infrastructure so that the credit card information is never in the open, right? And you just heard what Shankar was talking about, how he wants to get the BIN number. So his team doesn't need full access to the full credit card number, but a part of it. And there's another team, which is the customer service engineering team, and they're like, when customer calls in and like, look, I've forgotten my Netflix account, I have no idea what my email is that I used here, but I want to access my account, and I need help. And so we verify like a part of their credit card number to say, all right, so it looks like you have the right account, so we'll enable you, we'll reset your password and blah. Similarly, but then there's also the monthly billing cycle, where every month we want to talk to the payment processor, and at that point we want the fully decrypted credit card number. So in order to enable this, we considered a lot of tokenization solutions, but we wanted something that's reliable, available, scalable, in the cloud, multi-region, replicated, and so we had to build our own solution, and we called it Skee-Ball. Again, one of the talents of my team is coming up with cool names for security projects. Just as a side, one of the things we do is, first of all, do you have a good name? Do you have good logos? Can we get cutouts, stickers? Let's do the security project, right? So what we did was, when a sign up happens or like somebody updates their credit card number, the information comes into the payments app, and this is in line of the request. The payments app says, hey, I have this new credit card that came in, Skee-Ball service, can you give me a token? And then the Skee-Ball service says, all right, I'm going to generate a token for you, and then like also encrypt this information and store it in the vault. And in order to encrypt this information, I need the encryption keys. Now the encryption keys are in a separate service, are offered to us by a separate service called Cryptex, which is the only service that has access to the HSMs that are in the cloud. So if you think about how we have kind of like broken this down, the payments app never has all the tokens. It only has the request inline and like probably like a few credit cards and tokens that it is acting on right now. The Skee-Ball service has all the tokens and a bunch of encrypted blobs, but doesn't have the keys to de-tokenize it at any point unless it can talk to the Cryptex service. The Cryptex service has the keys but doesn't have the information that it needs to operate on. And then in order for, even though all these guys are in the secure environment, they need mutual authentication with client certificates in order to talk to each of them. So this is one of the projects where we kind of like build this solution and work with the Netflix billing and payments team. Fraud and abuse, again, like going off of Shankar's deck, is a concern for us. Specifically, you think about how we give away 30 days free trial for Netflix, and there's a lot of, again, those are localized, different, and we see different kinds of fraud happening in different regions. Like LATAM is big on like free trial fraud. Mexico is big on like credit card running, like stolen credit cards. There's account takeover. So all these concerns, and we don't want to just detect and prevent, right? That's that we can always do, but we also want to sanitize this data on an ongoing basis so that our billing and payment systems are clean, the forecasting and all the statistics we run are good. So we came up with Project Broomstick, which sanitizes stuff, right? So the way this works is we take sign-up data. Like, you know, when you sign up, we have all kinds of information, including your location, how you, like, you know, what is the locale you use, what's the location that it came from, your account attributes, you know, which IP, and how many profiles you created on each account, your streaming history, how many movies are being streamed per profile, how many devices are registered per account. Because all these, eventually, we can form a pattern of what's a legit account versus not, right? So you can think of somebody signs up from some place, but the streaming activity is happening completely differently. Of course, you're traveling, there are those outliers, but most of the times, we can kind of like see that some account is not legit. The attributes like multiple accounts being registered from the same IP address. Another cause for concern, we kind of like then look at, do you use like, you know, usually fraudulent accounts, they try to use the first name, last name, similar, and attach like a suffix or a prefix to kind of like move on because it's a script at the end of the day. So all this information goes into the Broomstick analysis engine. We have a bunch of static rules that we have figured out over time, and then like, you know, again, the DSC team helps us to identify some of these rules on an ongoing basis, and then we always A/B test, like if I put this rule, what would happen? If I did this, use this rule in detect mode, what would happen? And then of course there are these, we are now working on dynamic rules of like, can we just make up rules as we see these patterns and create the outliers, send it to a Hive table from where DSC team and billing team can utilize. So as you see, the whole feedback loop of this fraud information then pipes back to DSC, and they can say, you know what, this data, this swath of data, we can ignore that because something's not right about it. So we have a whole bunch of other projects. So right here is Scumblr. This guy goes out to the internet and says, anytime there's like mention of like, hey, Netflix account generator, or hey, I want to share my Netflix account with you for $5 on eBay, Craigslist, all that stuff. So we have a plugin for each kind of like place where you can like see pastebin credentials. So it goes and scumbles across the world and then brings in, and then so then we can take down that service, right? Its partner is Sketchy, which is up there, and that guy takes screenshots of websites. So we as security engineers don't have to look at this site and like probably infect our machine. So sometimes it might be a malicious site. it might download stuff. So Sketchy just takes screenshots, and then we are able to just go to Scumblr UI, go through this, and then say, oh, this site looks like this is just an account generator. This guy is trying to do much more nefarious, phishing, all that whole works. Dirty laundry, we still don't have we only have a good name. We don't have stickers or cutouts yet. But the idea is, what do we have hanging out there from Netflix that shouldn't be out there, right? So we continuously scan from a non-Netflix account. We continuously scan externally our infrastructure, continuously try to do web application attacks and see what we can find out, and then sift that data and then reach out to the team saying, really, did you want to expose this app? This was your hack day project. Did you really want to expose this to the world? This is some data that looks like you're exposing ESNs or whatever, or customer information. Did you want to do that? Did you intend to do that? And that's our way of going back to how we want to enable agile teams, is that we are not asking teams to come and enroll with us, or you have to, before you do this, you have to work with the security team and then we'll give you an approval of security before you do something. We are saying we'll enable them to be going as fast as possible while we can engage with them and help them in a proactive way. Speed Bump is another project where we are getting requests at the rate of more than 60,000 requests per second, and at each request we can make a decision of, do we want to block this request? Do we want to redirect it to some other place? Do we want to just log that this is something suspicious and make those decisions on the fly? And if one of our instances on the edge decides that, okay, something about this is bad, or this IP is bombarding us, or rate, needs to be rate limited, we are able to disseminate that information across all our AWS regions, across to every edge instance within 30 seconds, and we'll be able to bring down that IP if it is attacking us, or ESN, or customer. So again, we have a lot of stickers here. Ask questions, tell me what you guys think is interesting, and meet up with us later if you want to have more information. I have a whole lot of other security projects we can discuss, but for the purposes of this meeting, we'll stop here. Questions?
For your broomstick project, do you guys look at the metadata for the IP, like who owns it, when it was registered, anything like that?
We have a project called Lazy Falcon. So Lazy Falcon, you tell Lazy Falcon, hey, I got this IP, look it up. It does that for us. Questions?
Excuse me, in computation it sounds like everything is fully automated, which makes sense at this kind of scale, but you still have a bunch of manual intervention, maybe for very complex cases where your automated system just push some user account detail to some human operator or to just deal with special cases.
So the question is, this whole infrastructure looks very automated, but is there also manual intervention? Yes, we do have those. So we get, so Scumblr sometimes is not able to make a decision, or Scumblr says, okay, I found this whole bunch of credentials that some companies has been put out. We don't know if that's applicable to Netflix or not, so we have manual intervention right now to say, all right, so these are applicable to Netflix, so we'll help out, we'll scramble these accounts, but not the others and things like that. Yes.
For your dirty laundry project, you mentioned that you don't require internal teams to go through the security approval process, and they can pretty much launch anything without security approval. How fast can your system detect that there is unwanted exposed data during the application launch? And can you really afford that? Even a few minutes of unexposed data can be a problem.
So the question is yes, dirty laundry can detect and tell you about services that are exposing bad data. How quickly can you do that? Because yes, you can. Can you afford such a breach, if at all? So at the outset, very responsible, mature adults working here. So they are usually never happens, and we work off of the Netflix, the entire infrastructure, and we continuously scan this on an ongoing basis. And we have different sensitivities for different applications. So we are running at how many threads we launch against each application. We are very sensitive about that. But yes, a very valid question.
Do you do any
So the question is, do we do any DOS, DDoS prevention? And so the speed bump product is kind of like edge traffic management. And so not so much DDoS, but yes, DOS attacks can be prevented easily.
What tools do you use? You mentioned you use tools to enable your engineers to build secure products.
So what tools do we use for secure products? Again, going back to how you saw the interaction between the billing and payments team, every development team here has chosen the tools, frameworks, application stack, language that suits the best for agility for their product and their feature delivery. And as the security team, we are really excited that they are choosing so many different things. So we do the research and we engage with them and help them with those aspects. My team personally, we are good with Java, Python, Ruby.
I mean tools for security.
Oh, no. So we use burp proxy, the usual like app scan. What was the other one? So like a whole bunch of like the usual tools. Like we also have another infrastructure called Monterey, where we can enable any of these tools, like any of the typical security tools, Arachne, and then like launch a job of that against specific applications. So we can mix and match what we want to run against applications. How long do I have?
One more.
One more. Yes.
So when you present, it sounds like the systems are very mature and everything is going really smoothly. I'm curious, what are your biggest pain points and what do you struggle with?
So great question, solid question. Like how do we? It looks like super smooth. Everything is working great. How do you? What are the pain points? Again, the pain points are being able to reach out to different teams and saying, hey, we are here, involve us, and let's follow the best practices that we have already put out. Don't really create something on your own. Being able to engage teams because everybody has their own charter, and so like being able to plug into that workflow and really work with other teams. And usually we don't have that much of a problem that we usually think at a different company, but yes, that still exists because everybody is so focused on their stuff that we want to be able to integrate with them, not necessarily block them, right? I guess so. I'll give you the deck of cards though.